Okay, go ahead.
Welcome back, guys. We're back at it with another video. What's today? Thursday, whatever. Lesson 5.1, part 2. Ka-chow.
All right, before we continue with 5.1, we are going to go over these try-it problems from the example that we did yesterday. Remember that fun example that was actually 4 examples in one? Let's go over these. Now, as I was saying before, you guys are going to be tempted to rewrite this as a radical, which is not wrong, okay? So that would be the 4th root of 9 cubed, right?
So I was trying to
I thought it was. I thought 4 is in the inside because it's the lower one. Isn't 4 on the inside?
No, the denominator is your index and the numerator is your exponent. But, somebody trying to come in.
every time I stand up to go open the door, someone else stands up every time.
So, while this is a correct way of writing this value, this is not what we're looking for. We're actually looking to break down this 9 and simplify it with rational exponents, okay? Oh, you did switchies?
Yeah, get through there.
Okay. So instead of writing it like this, we're going to rewrite it simply with a base and an exponent. Let's see what it comes out to. Well, how can you rewrite the number 9 with a base and an exponent?
That one.
How can you rewrite the number 9? Well, with the, okay, let me write it over here. Just like forget about this for a second. I want to write number 9, but I want to write it with a base and an exponent. Hermione.
3 to the second.
3 squared, very good.
Huh?
Do you agree that 9 is the same thing as 3 squared?
Yeah.
Yeah.
Yes.
Do you agree, Angus? Okay, good. The number 9, the value 9, is the same thing as the value of 3 squared, right?
Yes, it is.
Sure.
Okay, if that's true, then I can rewrite this 9 as 3 squared, and I'll rewrite this entire expression because the 9 has the power of 3 to the 4th, so I would have to raise this to 3 to the 4th, and then I can use a property,
Multiplication.
yes, power to a power, multiply your exponents.
Exponent.
What?
Exponent.
Yeah, if exponent is being exponented.
Over 4.
Okay, so then we can just use our reduce before multiplying rule if you'd like to. And you can reduce your 2 over 4 to 1/2. And what do we get? 3 to the 3 halves power. So 9 to the 3/4 power is exactly the same as 3 to the 3 halves power.
Why did you change your denominator?
So like me.
Why did you change your denominator?
Say it really slowly. Why did you change your denominator?
Yes. Why did you change that to 6?
This?
Because she canceled it out. Like.
Oh, this? Yeah, because my numerator over here was 2, my denominator over here was 4. 2 over 1 times 3 over 4. I can reduce these.
You have to.
No.
Or can you just like do it at the end?
You can do it at the end, but I'm just gonna be honest with you guys. I'm not really sure why so many of you don't use this trick because it's a really simple way.
I just like to reduce it.
You like to reduce it at the end?
Yeah, me too.
Usually if you wait to reduce it at the end, you can forget to reduce it or you don't see it as clearly.
Try it out. Reduce.
Okay. You guys do you, okay? If you end up with 6 over 4 and you want to reduce it, that's fine with me. Just don't forget to reduce it, okay? So we get 3 to the 3 halves power. Let's do this guy. Can I erase this?
Yeah.
Oh, great. Getting blue smudgies everywhere. That's not good. Okay, so now I have, excuse me.
That's not good.
That's not good. Okay, so now I have 49 to the negative 3 over 2 power. How can I rewrite 49? No, nobody say it. How can I rewrite 49 with a base and an exponent? You can do this. Rewrite the value of 49 with a base and an exponent. Do you think that's helpful for his thinking process?
Yeah, sure. Sorry.
I love that you know and you want to help, but pause yourself for a second.
It's okay.
Howdy.
Sorry, I'm
Grayson.
trying to figure it out.
Okay,
For real though, I'm trying to do some math here.
okay.
Seriously?
He's trying very, very hard. His calculator's up. What are you punching into your calculator?
Different numbers to multiply for that.
I
And
know.
then just divide them, and then just take those numbers.
I know. So you're trying to find numbers that will multiply together to get what?
The base and the exponent.
The base and the exponent?
Yes.
Okay, so my question was, how can we rewrite the number 49 to have a base and an exponent?
Divide.
Grayson, I know guys, we have, to rewrite the number 9, we did 3 squared. What can 49 change into? Can you think of a number
No.
that can be raised to a power to get 49? Jocelyn?
7.
Just in the nick of time. 7 to the what power?
Second.
Yeah, second or 7 squared. Very good. So we can rewrite the number 49 to be 7 squared, but that also has to be raised to the negative 3 over 2 power. What do we do with our exponents? What do we do, Angus?
Yeah, what are you doing? Is I'm very curious.
Angus, what do we do with our exponents? We have a power being raised to a power. What rule do we follow? Don't say it, Grayson. Angus, what do we do? Wrong answers are okay, but give me an answer. I have a power being raised to a power.
I swear I didn't jump in.
What is the rule? What do we do with our exponents? Grayson, it's not helping at all.
I'm so sorry.
I'll give you a hint. It's either add, subtract, multiply, or divide.
I said divide at first.
What?
I said divide at first.
Oh, okay, we're gonna pretend you didn't say that.
Okay.
Try to pick a different one. Do you
Multiply.
Yes, it's multiply. We're gonna multiply our exponents.
You are?
2 over 1 times negative 3 over 2. If you don't like reducing before you multiply, then turn away. Okay, but that makes it really, really, really easy.
But then the
Negative.
negative is go jump the dungeon.
It does, but let me rewrite it. Let me write it first and then we'll send it down. So we have 7 to the negative 3 power, and Faith is right. It's gotta go down to the dungeon.
1 over 7 to the
1
third
over
power.
7 cubed. And then we just get out our little calculators.
I don't know.
343.
Good. 1 over 340.
I got this.
No, we got it already, Bo. We got it.
343.
Thank you. Okay, are we good with those two?
Sure.
Okay. Ready for this one? Me neither.
No.
What?
I think I have my answer, but I'm not really
Is
confident.
this the answer?
Oh, yeah, me too, please.
No.
Okay, here. It's number T.
What am I looking at? That, no. Anybody else think they got the answer for C? No?
I thought my mess.
Okay. It's really hard
Yeah.
not to make a silly mistake on this. There are
Oh, I
so many steps. Even when I was doing it in the last class, and I've already done this problem a million times and I know how to do it, I made a silly mistake by squaring something instead of cubing it. Like there are just so many, it's like 10 problems in one.
Wait.
So let's work it out step by
But
step.
I didn't do the exponent like out of the points.
Oh. So we're going to solve it step by step. There's a lot going on in here and a lot going on out here. I'm gonna rewrite it so we can see it a little bit bigger. 3g, everybody's copying this down, right? 3g to the 7 over 3, h to the negative 3, k to the negative 5 over 5g to the negative 3, h to the positive 5, k to the, does that say negative 5 over 2?
Yeah.
Yes.
Negative 5 over 2. And then this whole thing is being raised to the negative 3rd power. That's a lot of stuff going on.
That hurts my brain.
All we have to use is basically every tool in our toolbox. Now, you're right. One of our tools is flipping.
I just randomly said flippies. I'm like, okay.
Oh, really? Okay. What a coincidence. You can do flippies first. You can.
Sorry, I didn't even do that.
I would wait to do flippies because there's so much in here that can be simplified. It'll be easier to flip when there's not so much to flip. Instead of rewriting this all over again and then simplifying it, we can simplify first and then flip. Yeah.
If I did flip, would I flip everything or would I?
Everything. You would literally write it over, write this entire thing on top and this entire thing on the bottom with their exponents exactly the way they are.
If it's positive.
Then you would raise it to the positive 3 power, and then you would have to simplify everything inside. It's just complicated. So we're going to simplify what's inside here first. Keep it raised to the negative 3 power. Watch, I'll show you. So we're going to keep it to the negative 3 power for now. We'll do flippies next. We're going to keep it raised to the negative 3 power for now, and we're going to simplify what's inside. Can I do anything with my 3 over 5, or is that simplified? No, yeah, that's as simple as it's gonna get. Okay, what can I simplify?
G.
G. What do I do with my exponents?
Minus.
Yep, you subtract them. Angus, do you agree? Okay, do you get all this down? Everybody put your hands up for a second. You need to get this down. Can you write it? Why not? No. But this one needs to be written down. We've been sitting in class for 20 minutes, 30 minutes actually.
We
Thank
have.
you. Did you get it?
Way.
You got it? Okay, good. You got it? You got it down? If I check your notebook, you can put your hands down. I said put your hands down first. Did you already write it down? Or did you do it after I said? Are you ready to do it? You have it? You have it? Good. You have it? Good. Why not? Why aren't you taking notes? You think you don't need to know it? You guys got it? Well, do you feel like you're gonna remember every single thing that I did? Or do you think it would be a good idea to take notes?
You check boundaries.
Yeah, you are.
She literally just checked.
And literally did it.
Literally.
Alea,
Literally
take
boxing
notes.
fish.
Follow along and take notes. But it's going over the, okay. Take notes on everything. Everything that we do in this class, take notes on.
And like.
Unless I say, don't take notes on this, which I will say on one of the examples coming up. Okay. Let's not waste class time for me having to check that. We need to be writing everything down. Is your pencil still in your hand? Good. On your notebook. We're doing this, okay? Subtract our exponents. That means G, I'm going to write it over here. G to the 7 over 3 minus negative 3. Put that in parentheses to protect your signs.
Wait.
Then what do I do?
Wouldn't it be G to the negative? No, I'm not gonna be that.
No, I'm subtracting my exponents.
Yeah. So you,
I will in a second, but
Kill cockroach change.
yeah, first I'm gonna take care of my signs. Kill the cockroach, change the sign, and then I will put everything into fraction form. So I'll have 7/3 plus what? I need a denominator of 3. So I would change my 3/1 into 9/3. Very good.
Wait,
Because-
wouldn't it be 10/3? Because 7 plus 3 is 10.
No, 3/1 with a denominator of 3
Oh,
would be 9/3. Now I have g to the, anybody? 16/3 power, and now I can write that. It goes in the numerator. G to the 16/9 power.
That's a big power.
Yep. It's very powerful. I'm just gonna cross out everything that I'm done with and move on to my next
so
variable.
basically killed that G on the bottom.
No.
Yeah, it's basically, it's just simplifying them, it's bringing them together. Shh. What do I do with my h's?
You subtract.
Subtract the exponents. H to the -3 minus 5. Kill the cockroach, change the sign. What do we get? Good. H to the -8. I could put it up here.
But you wouldn't.
Technically, if it's a negative, technically, if I just am gonna write it and forget about it, I would write it in the numerator. But since it's negative, I'm going to send it to the denominator and make it positive.
The denominator
H
is
to the
mentioned.
+8. Would you not? Yes.
Did you get 16/9?
Was it 16/3? Uh-oh. See, I told you I make silly mistakes. Well, check your notes. I erased mine. Was it six? Was
Yeah,
it denominator
16/3,
3?
yeah.
Okay, sorry. 16/3. On Monday, I'm going to have Jolly Ranchers. They arrived at my house,
Nice.
but I didn't bring them in, and I'll be here on Monday. I'll remind me that I owe you a Jolly Rancher. Okay? So, she'll remind me. I'll believe her. I won't be like, show it to me on paper. Okay, so we're done with our H's.
We have it on video.
I do. I have the evidence on video. All right, one more thing to simplify inside. We have our K. What do I do with my exponents? Angus, what do we do with my exponents?
Multiply.
What makes you think we multiply them? It's not the same situation as before. We're on a totally different problem.
Divide them?
No. I'll give you a hint. We just did it with these exponents and these exponents. We're gonna do the same thing. Did you write down what we did? Gotta follow along, okay? Everything that I write, you write. I have to erase it because I run out of space, but you have lots of notebook paper. You have to keep writing, okay? Grayson, what do we do?
Subtract.
Subtract the exponents. K to the -5th power minus 5/2. This is a total pain because there's negatives and, yeah,
It's a negative.
what?
It's a -5/2.
Oh, thank you. Jolly Rancher Monday. Minus -5/2. This is a huge pain. We've got fractions that don't have, we've got fractions and whole numbers. We've got negatives, we've got subtraction. It's a pain. See all these silly mistakes I'm making?
Yep. Kill the
Kill the cockroach,
Change
change
the
the sign. That means I have to add -5/1 plus +5/2.
You can't put them in.
But I can't because I need a denominator of
2.
2. So what should I change this to?
10/2.
-10/2.
Negative 10.
Because that equals -5. So it's K to the
15th of a
-10 plus 5.
5/2.
-5/2. K to the -5/2 would go up here with a negative attitude. That's not good. So we're gonna send it to the basement with a positive attitude. K to the +5/2. Now we can do
Ow.
Bye. Okay. I'm gonna erase this part. We're
This
done.
leg,
Yeah.
may I please go to the water fountain?
He doesn't even kiss.
You
I
got-
want water.
You don't have any water in there?
There's barely anything.
Okay. You're gonna miss this.
I'm sorry.
All right.
I will copy.
Now we can do flippies. This is 5, right? Now we can do flippies.
Do we have to put that entire thing under
So
one?
I'm gonna flip everything. Everything in the numerator is gonna go in the denominator. That would be 3g to the 16 over 3. Everything in the denominator goes in the numerator. That would be 5. H to the 8. K to the 5 over 2. And it's still being raised to a power, but now it's positive.
Yes!
There's one more thing we need to do. Charlotte, what do we do?
Oh!
And in what way? So everything inside of here has been simplified. That's what we were just working on for like the last 10 minutes. We simplified everything. Everything that could be simplified was simplified. And then we did flippies. And there's one more thing we need to do. Faith?
You do have to simplify, but it would be, we're doing, what are we doing?
This.
Never mind, okay.
Carmine.
You multiply that 3 with everything.
Yes, you cube
Took
everything.
my answer. I had it up in here, which.
Okay. Yeah, we would distribute, which is probably not the right term, but that's what I say.
Backwards.
Distribute this cube to every single part of this term. Every single part. That means the 5 gets cubed. That means the h to the 8th gets cubed. That means that you get cubed, and you get
I
cubed,
get
and
cubed?
you get cubed, and you get, it's like that Oprah thing.
I'm a cube.
You get cubed, and you, no, okay, never mind.
You get a car.
Yeah, you
die.
get a car, and you get a car, and you get cubed, and you get cubed, and you get cubed. We're all getting cubed. Wouldn't that be nice? So now, we're gonna cube everything. Lily, help me start. You don't need to put the cap on. Yeah, because we're still working, right? You can stop the doodling, but you don't need to put the cap on. What would be the first thing that I do? What did I just say that we have to do? Cube what? Shh, shh, what? So just the numbers we're gonna cube? What did we just say? I said cube everything. Very good. If I'm gonna cube everything, I have to start somewhere, right? Where do you think I should start?
Right there.
What? Okay. Well, usually we like to go in order from left to right, right? Great. Let's cube that 5. What's 5 cubed?
50.
125. If you don't know that by heart, that's okay. We have calculators. 125. Here's the tricky problem. Are you gonna pick on something they're not gonna like it? Alea.
Oh, sure.
What is h to the 8th cubed? What is the rule that we follow? Turn around. So, do you agree that this is an exponent, or what we would call a power, right?
Yep.
Is this power being raised to a power? That reminds me of a rule that we need to follow. When a power is being raised to a power, do you know what? Yeah, if your exponent is getting exponented, what do we do with our exponents? Nothing? Yes, Bob.
You multiply the exponents.
You multiply the exponents. So what would h become? H to the, you would multiply your exponents. So what would I put here? Yeah, you still. H to the 8th
So I'm
Cube.
typing 2 times 8.
Yeah,
Oh,
okay. It's okay, can somebody, you have a calculator right there. If you, just somebody shout it out.
24!
Okay. H to the 24th power times K to the, what do we do here? Multiply your exponents. So what would it be? 5 over 2 times 3 over 1. I can even put it over 1 if you like. 15 over 2 is correct. Now what do we need to do?
Multiply 3 by 3. By g to the 3 times 3.
Good. We're going to cube the denominator. 3 cubed is
That one.
27. I actually put 9. It's okay. I put 9 last class. It took like 5 minutes and somebody finally was like, how'd you get 9? And I was like, 3 cubed. Oh wait, okay, it's 27. Did the same thing, silly mistakes all around. Now we have g to the 16 over 3 to the 3rd power. What do we do?
Now, you multiply, but now if you think about it, you can cross cancel, and it would just be 16.
It would just be 16. G to the 16. Now
Yours was 16.
we are done with
That
that
was ugly.
problem.
You could be done with class.
All of that work, and now it's gonna get erased so we can do this guy over here. This one's much simpler.
Imagine we're taking like the entire class. This is you now.
Well, we really want to make sure that we know it, and I'm noticing that at least half the class is not really taking in a lot of this, which is very sad. I'm up here doing all the things, and you guys are out there doing almost no things.
Oh, this is the one
Okay?
that like I had. That made me go mentally.
You do?
Yeah.
Tell me.
So you have to do the 5,
Okay,
and then 2t as an exponent.
okay,
And then you have to do times
Oh,
that
yeah.
by 5 to the 3rd exponent.
Very good. You were the first person, the only person all day who has been able to do this. You did it too? Good job. You did it too? What are you guys, a bunch of geniuses?
Yes.
Great job. What? Good. That is correct. That is good. That is our answer. Very good. All right, we're gonna break it down. What Faith just did, and what some of you did, is you said, hey, in this exponent is an expression where 2 things are being added. I know a rule where exponents have to be added. That was when the base was the same. It was being multiplied, and we added the exponent. So we're undoing that property. We're going backwards for that property. Now, what's the benefit of doing that? Is there something I can simplify here? Is there a benefit? Yeah.
You can do 512t times
512.
Oh wait, no. Is there something, I can't simplify the 5 to the 2t power and get a number, but I can do 5 cubed, right?
125.
Yeah, I have to move along a little bit. 125, as much as I would like to pause and ask you guys every single question, I really do. I just don't have that kind of time. So I have 5 to the 2t power times 125. Is there a rule about, what are 2 and t, what are they doing together?
Multiplying.
They're multiplying.
So if you
Isn't there a rule where you have to multiply your exponents?
No.
Alea, didn't I ask you before what to do on something? And then we ended up, you got some help, but we ended up saying that we were gonna multiply the exponents, right? What caused us to have to multiply our exponents? What situation was in front of us that made us go multiply the exponents? Remember? You're right.
The exponent is being exponent.
If the exponent is being exponent.
I didn't understand what you were asking though.
It's tricky because we're going backwards. I said before we had to multiply our exponents, what caused that? Because the exponent was being exponented, the fancy way, the book way of saying it is a power to a power, or a power being raised to a power. If that's the case, then can't we rewrite this as 5 squared to the t power. What's the benefit of writing it like that?
Go backward.
Yeah. What's the benefit of writing it that way?
So now you can solve the 5 without the
Yes,
t
now we can do 5
Five.
squared is 25 to the t power times 125. Am I allowed to do 25 times 125?
No.
Because of,
Oh yeah, you're late.
Because,
starts with an O.
Oh,
Why am I
order of
not?
operations.
Order of operations. This exponent is saying, nope, you're not allowed to multiply my base until it is exponented. And we can't exponent it because it is a t,
Is that even a
not a
word?
number,
Is that a
okay?
word?
And therefore, we are done.
Oh, we're done?
Wait, you don't.
So this is your final answer.
You don't solve it?
You don't.
You
don't
cannot
do
simplify
5
that anymore.
You don't do 5 times 5 and then 25.
Wait, what?
Like in the parentheses, 5 to the second power. You don't like. You don't do that.
We did 5 squared is
Oh,
25.
oh, I didn't see
Yeah,
that.
this is the final answer. Okay. All right, here we go. This we have already done. I have already taught it to you, but something tells me some of us need a quick little review. So we're good. You need to follow along if you are having trouble with your properties right now, okay? If you're not having trouble, follow along anyway. The book thinks that I didn't teach this to you yet because the book doesn't know that I found the old book and taught from there. So the book is teaching you about the same base property. So we're just gonna follow along and say, oh, I wonder what you do when your bases are being multiplied and they're the same. I wonder what you do, Lily. Can you? The book thinks we didn't learn this yet, but we did. When the bases are the same, what do we do with our exponents? When the bases are the same and they're being multiplied, what do we do with our exponents? No, I'll give you a hint. It says it right there. Yeah. When the same bases are being multiplied, you add your exponents, okay? We've been doing this, we've been taking notes, we've been having open note quizzes, we've been doing all these things. We really need to make it a thing that we know. Okay, so hey guys, look. The denominator is 5 on both of those exponents. Isn't that great? And we can just add the numerators. 27 plus 18 is 45. This exponent can be simplified. 45 divided by 5 is what?
9.
9. So this is simplified to 3 to the 9th power, which of course you could put into a calculator and get
19,783.
this. 3 to the 9th power is fine. Everything okay?
Yeah, suppose it's being
She's being a goofball.
Just go.
May I have the last few minutes of class, or would you like to not learn? Thank you. Oh, oh heck. We just went through multiplying same bases. Now they want to teach me dividing same bases. I wish I had learned this before. This is all so brand new.
No.
We already know this, right? Is there anybody who already knows this? That was in class the past couple of weeks? That we've been going over it? Yes.
I wasn't here.
When you have the same base and it's being divided, what do we do with our exponents?
Subtract it.
You subtract.
Subtract.
So when we subtract, oh no, we don't have the same denominator. So when we subtract, we just have to change this 11 over 2 to 22 over 4, right? 11 over 2 equals 22 over 4. Now I can subtract my numerators and get 5 over 4. 6 to the 5 over 4 power.
That's a lot.
Thank you, book, for teaching us our properties. So glad. Now we can learn so much more.
You sound like Doug from the movie, the dog.
Okay.
Doug.
The bark?
Yeah.
This is the last thing I want to teach you, and it is a beast. Okay? I'm going to go through it quickly. You're probably not going to understand it, and that's okay. I also have a homework video where I go through it really, really slowly. But we still need to work on paying attention and focusing so that we don't end up with no time at the end of class. Don't worry about what this says, we'll get to it. Everybody's on a little picnic and they've brought their blankets except for this family who lost their blanket, okay? And they're just on this rectangular piece of grass. They want to know what is the area of this rectangular piece of grass. To find the area of a rectangle, what do we need?
Length and width.
The length and the width. Because the area of a rectangle equals length times width. Very good. Now, the book for some reason is calling this the length and this the width,
That's
Which
right.
which is weird
incorrect.
because
Backwards.
usually we would give the
But it-
longer side the length, but it doesn't
It doesn't matter because multiplication can go both ways.
technically, yeah. So I am gonna let them know about this because I do think it should be the other way around, just to be consistent, just like we like things in alphabetical order, can you not with the tapping of the pencil? But technically doesn't matter, so it's not an error. It won't cause an error in the calculations, but it's a little strange. But just for kicks, we're just gonna go with it so that it stays set up the same way. So we're gonna call this side our width and this side our length, even though it probably should be the other way around, doesn't matter. Do you agree that in order to get this area, we need the length and the width?
I believe so.
Okay,
Yes.
there isn't any information that straight gives us the length and the width. But the length of this rectangle is also one side of this square blanket. So the length of this
Wait.
is the side of a square that has an area of 8 yards squared. So let's go over here. Area of a square, you could also say length times width, but if we want to be really specific with our formula, that's just for a square, what would we say? Just a generic formula, not numbers, yeah. Yep, side squared or side times itself, right? Because a square has equal sides. So a square area formula can be simply put as a side times itself, or a side squared, okay? Now, if it gives us the area, and it says the area is 8, that means 8 is the area, and that means the side length of the square, when it's squared, will give us the area. How do I find out the side length?
Divide.
Nope,
Oh.
not divide. What's the opposite of squaring something? Square rooting it. The opposite of squaring it is square rooting it. So, in order to get the side length, I would need to find the square root of 8. Tell me another way to write the square root of 8 with an exponent.
So you do that little squiggly thing, and then you have the 2 on the outside. For the exponent.
Not quite. Oh, I know what you're saying, but not quite.
8 to the 1/2.
8 to the 1/2 power. And I'll show you why. Oh, no, I can't show you why.
Oh.
Bye. Watch the homework.